Hi friends, welcome to Ivy-GreGMAT GMAT quant intro session probability. Let's get started. Probability. The probability is that a specific event will occur. Is the ratio of the number of occurrences to the number of possible occurrences. So this is like fairly very simple that when we look at probability, it is something like an event will occur. So P is equal to N by N. If I put this formula, this is the number of actual occurrences versus the number of possible occurrences. There is another way of looking at probability, that a specific event will not occur. Will occur, this is the formula. Will not occur, it is 1 minus P. So if Q is what we say, it is not going to happen. So it's 1 minus P. Now how this comes? I can express probability as a fraction, as in a percentage, also as a decimal. So the probability of an event occurring for sure is 100%. So if that is the case, which is equivalent to 1, if I take it on a fraction. So an event not occurring Q is 1 minus P. So the probability of an event occurring is 40%, which is 0.4. If this is the probability, then Q is 1 minus 0.4, which is equal to 0.6. That's how we put it. So having said that, let's go to the next part and understand the basics of probability. So what if a coin is tossed? There are two equally possible outcomes when we toss a coin. It can be a head, it can be a tail. So the two possible outcomes, equally possible outcomes, are head or a tail, designated by H or a T. Now, the probability of head is H by H and T. Possible outcomes are H and T, which is 1 by 2, which is 50%. The P of tail is T by HT, which is again 1 by 2, which is equal to 50%. That explains that the probability of head and tail is 50% each, because the total number of possible outcomes are 2, either head or tail. So let's roll a dice now. There are 6 possible outcomes, which can be, if I roll a dice, which can be 1, 2, 3, 4, 5, or 6. So the total number of possible outcomes are 6. So the probability of getting a number, any number between 1 to 6 is 1 by 6. Fair? Now let's complicate it a bit more. Let's assume that we have a jar of 10 green and 90 white marbles. If we randomly choose a marble, which is what is the probability of getting a green marble? So here n, the total number of possible outcomes, is equal to the total number of marbles, that is 10 green marbles plus 90 white marbles. That makes it 100. The smaller n, the actual occurrences may be the total number of green marbles, 10g equal to 10. So the probability is equal to n by n, 10 by 100. This is 1 by 10, or we can say it's 10%. Now there is a twist here. What if there are successive events when one marble is picked up and it is not a green marble and it is not replaced? Then the probability will be 9 by 99. So this is something with replacement, without replacement will be given. So if it is given, then I know that out of the 100 marbles, the first one picked was white. So now you're left with 99 marbles. The second one picked, say, is white again. So the total number of outcomes are going down because the number of the marbles are not getting replaced. So it becomes 98 now. But this is without replacement. But if we replace it, then this 100 remains 100. Then this remains 100. So our n will differ in both the cases, right? So let's move on to something more complicated, or rather, let's just quickly see the concept here. Whereas in case of a coin or a dice, the probabilities are always the same because it's 1 by 6 or 1 by 2, because there is nothing like a replacement. The numbers remain static from 1 to 6 or head or tail. Usually, a problem explicitly will state whether it is a replacement or it's without replacement. Okay, folks. Now, something we need to understand here. Independent events, what are they? And there will be something called as the exclusive events, or mutually exclusive events, as we say. Let's see, what are independent events? Two events are independent if occurrence of one event does not influence the occurrence of the other event. Event 1 if it happens, it does not influence event 2. The two events are independent of each other. So there is no dependency. Then the probability of, say, event 1, event 2, and event 3 to event n will be P1 multiplied by P2 multiplied by P3 to Pn, as we see here. Or for our convenience sake, we put up this formula where A and B denote independent events, which is P A and B. P A multiplied by P B. We'll be using this, so this is one important note here. So let's go to the next part and see how we can use it. So there is a coin and there is a dice. So if we flip a coin, if we toss a dice, One doesn't have a bearing on the other. They are two independent events. So after one flip and one toss, what is the probability of getting a head and a 4? So two independent events, two probabilities will be generated. So let's see. Probability. So I'm sorry. Probability of getting heads or H is 1 by 2. The probability of getting a 4 when we toss a dice is 1 by 6. So the probability of getting heads and a 4 is 1 by 2 because they are independent events multiplied by 1 by 6 is equal to 1 by 12. Now let's look into another question. If there is a 20% chance of rain in London, what is the probability that it will rain on the first day but not on the second? Rain in London, very common. Okay, so let's see. Probability of rain. Probability of no rain. 1 minus 0.2, 0.8, as we saw. So probability of rain one day and no rain on the second day is equal to 0.2 multiplied with 0.8 is equal to 0.16. Two events independent, as the first day's event does not influence the second day's event. Now don't become a climatologist and try to find out that okay, the rains on the first day. No, we are doing mathematics, so this is the thing. Let's go to the next one. There are two sets of integers, 1, 3, 6, 7, 8, and 3, 5, and 2. So let's call it set A. Uh, 1 second. So let's say set A is 1, 3, 6, 7, and 8. So there are 1, 2, 3, 4, 5 numbers are there. Set B has got 3, 5, and 2. So this is like 3 numbers are there, 3 integers. So set, it is saying that if Zian chooses randomly one integer from first set and one integer from the second set, what is the probability of getting two odd integers? Okay, from the first set, the probability of getting from set A, probability of getting an odd integer is 1. 2 and 3. There are three odd integers, 3 by 5. The probability of getting an odd integer from set B, so let's call it PA and PB. It will be, I'm sorry, this will be 1 and 2. So 2 by 3. The probability of getting an odd integer from the second set will be 2 by 3. So the probability of getting two odd integers P is equal to 3 by 5 multiplied by 2 by 3, which is 6 by 15, which if we knock off is 2 by 5. That explains. Okay. Now the second type, mutually exclusive events. Two events are mutually exclusive if they cannot occur at the same time. They do not occur at the same time. So two events cannot occur at the same time. So one event has to be completed, followed by the next event can occur. Clear? So if that is the case, then the total probability P is actually probability of event 1 plus probability of event 2 plus probability of event 3 to Pn. Or we can say P A or B. Why we are writing A or B? Because if A occurs, B will not occur, B occurs, then A will not occur. So in that case, P A, the total probability, P B, where A and B denotes mutually exclusive events. Let's take a few examples. It will make it very easy. If Jessica rolls a dice, what is the probability of getting at least a 3? Note the words, at least a 3. So the total number of outcomes are 3, 4, 5, and 6. So it's 4 outcomes. The total number of outcomes are 4. Of getting at least 3. And the probability of each outcome is 1 by 6. Hence, probability of getting at least a 3 is, so this is P, it will be 1 by 6 plus 1 by 6 plus 1 by 6 plus 1 by 6. We solve it, it is 2 by 3. We did not multiply, we added up, because if 4 happens, 5 will not happen, 5 happens, 6 will not happen. So, and if 6 happens, 3 will not happen. I mean, they are all mutually exclusive events. So a combination of independent and mutually exclusive events, many probabilities problems contain a combination of both independent and mutually exclusive events. To solve these problems, it is important to identify all the events and their types. So it's basically whenever I look at a probability question, at least I will have to do this much. To identify it is independent or mutually exclusive. Let's see. What is the probability of getting three heads while tossing a coin 8 times? A coin is tossed 8 times. So what's the possibility that will be three heads? Let's see. Let H stands for the H for heads. Let T stands for the tails. Fine. So it can be something like heads, heads, tail, 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 tail. 1, 2, 3, 4, 5, 6, followed by a tail and a head. This can be one set. Or it may so happen that it is head, 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 followed by 5 tails. Tails, 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 tails. Or any other combination. These two events are mutually exclusive. If this happens, this will not happen. And if this happens, this will not happen. The probability of head or tail is 1 by 2, which is equal to 0.5. So hence, to draw the total possibility for an event occurring 8 times, we'll use a simple formula where we'll take into the consideration the selection of certain objects. So this is 8 times. So it will be, this P will be NCR multiplied by probability to the power R multiplied by 1 minus P to the power N minus R. So let's fix this formula. P is equal to 8CR, which is, I'm sorry, let's 8C. There are two possibilities. 3 heads multiplied by probability is 0.5. R is 3 multiplied by 1 minus 0.5 to the power N minus R. That's 8 minus 3. Okay. Let's do a sum which will make it more easier. Let's see. The probability of getting a rain on any day in Mumbai is 40%. What is the probability of getting probability of raining on exactly 2 days in a period of 7 days? So in a week, 2 days of rain are expected. What is the probability? If the probability is 0.4, so the probability of rain is equal to 0.4 or 40%, whatever. Exactly 2 days. Then we have got P is equal to NCR multiplied by P to the power R multiplied by 1 minus P to the power N minus R. Let's fix it here. P is equal to 7C2 multiplied by 0.4. The probability is R is 2. multiplied by 1 minus p, which is 0.6 non-occurrence. N minus r is 5. If we solve this, we get the answer. A different variant, just if something like this happens, then this is something that can be handy. A few ways to approach a probability problem. Okay, I mean, that's really important that we'll take one question and we'll try to solve it in multiple fashions. Let's see. There are 8 players in a top league, and that includes Ronaldo and Bebeto, great Brazilian players. If 2 players are to be randomly chosen to form the national team, what is the probability of getting probability that the team includes both Ronaldo and Bebeto? So 2 people have to be chosen who have to be there. What is the probability that my choice will have these 2 people? Sure shot. So total possible outcomes. So there are multiple approaches. Combinatorial approach, that is like using the simple formula, total number of possible committees are, or total number of combinations. N is equal to 8C2, which is basically factorial 8 by factorial 6 multiplied by factorial 2, which is equal to 28. So the number of possibilities that both Ronaldo and Bebeto are chosen is the total N. Now N is the number of possibilities of having both of these folks is equal to 1. So the probability is 1 by 28. This is probability of both Ronaldo and Bebeto. Total number of possible outcomes 28 is equal to 1. So, and the actual occurrences is 1. So N by N. Okay, once we are done with this combinatorial approach, we can take this reversal of combinatorial approach. Let's see how we can do it. The reversal of this approach. How come? We know that the total number is equal to 20. So 8 outcomes are possible. I mean, that's the maximum possibility. Now, we go the other way around. If 28 is the total number of possible approaches, which is actually come from this formula, n is equal to 8C2. So then the number of outcomes where Bebeto and Ronaldo are not going to be there. If that is M is equal to 6C2, wherein any of these 6 people, the rest of the 6 people are going to be chosen, or 2 into 6C2, where either of these 2 guys are going to be chosen. So this is like any other 6, and say this is either B or R. In that case, the probability, the reversal combinatorial approach, the probability will be 1 minus m by n, which is 1 minus 6c2 plus 2 into 6c2 divided by 8c2, which is again 1 minus 27 by 28, which is 1 by 28. We get the same answer through two different approaches. Let's see some other approach if we can have. Okay, the probability approach. What is the probability approach? What is the probability of an first event or the probability of the second event? See how we can do it. Mm, One second, let me change the pen. Say probability of B or R on the first case is 2 by 8. The probability of B or R in the second choice is 1 by 7, because if either one of them is chosen, because as this is because as B or R is already chosen. If that is the thing, then total probability is equal to 2 by 8 multiplied by 1 by 7. This will make it 2 by 7. It's a 56. That will make it 1 by 28. Okay, so now the reversal probability approach. This can be like fairly very simple. If you are having a situation where you are taking the reverse of the approach we had just learned. I mean, the reversal of probability. Say number one, it may be uh, B or R or any other of the six as the first choice. So that makes it 2 by 8 multiplied by 6 by 7. Or if neither B or R as the first and then the remaining 7, it will be P is equal to 1 minus 2 by 8 into 6 by 7 plus 6 by 8 into 1. This is equal to 2 by 26, which is, sorry, 2 by 56, which is 1 by 28. So again, we are getting to this number in multiple approaches, whichever suits you or whichever suits the question. So that should be the approach. Well, sometimes this can give you a tough time. Probability can give you a tough time because the length of the question. Look at the length of this question. But when I look at this question properly, I find out that mm, Julia and Brian play a game in which Julia takes a ball, and if it is a green ball, she wins. If the first ball is not a green, she will take the second ball without replacing the first, and she wins if the two balls are white, or if the first ball is gray and the second ball is white. What is the probability that Julia winning if the jar contains one gray ball, two white balls, and four green balls? In this kind of a situation where it looks a bit difficult to visualize what is going to happen, we can just put it like this. The first choice, there are three probable choices. white ball, a green ball, or a gray ball. Green stands for G and the other three choices. The chance of white ball is 2 by 7. This is 4 by 7. And the gray ball is 1 by 7. If she gets a green ball in the first choice, she will win. She wins. So if it's a green ball, she wins. If it's a white ball, this can be followed by a white ball. That chance is 1 by 6. Then only she wins. If she gets a gray ball, this is followed by a if she gets the second ball, she will win if the two balls are white balls. Or if she gets the first ball is a gray ball and the second ball is the white ball, and second ball is the white ball, that probability is 2 by 6. Now these are the three ways in which she can win. Then the number one way, number two, and this is the number three. Now that makes it more or less clear. So the probability of Julia's win is P is equal to 4 by 7, this 4 by 7, plus 2 by 7 multiplied by 1 by 6, this one, plus 1 by 7 multiplied by 2 by 6. We solve this, we'll get 2 by 3. Clear? So this kind of a question comes, it's basically a time killer. It will take some time. So do not get surprised that it cannot be solved or it's a long question. No, you will have to draw something called as probability tree. That's it. And then put it in this equation, it will come. Right, folks? So thank you. That brings us to the end of this chapter, probability.